All right, good afternoon. So second part of the second section on the chapter, the number of elements in a set. So this time we're going to get closer to actual doing real stuff in terms of probability theory. Not yet, we're not going to talk about probability yet, but counting is the essential part before we handle interesting applications of the probability theory. Let me give you a little motivation what we mean by counting, because mathematicians that work in this area always talk about this. Okay, so how do we count, and tricky counting problem, so on and so forth. And stands the reason that it's not like we have to learn how to count from 1 to 10. That's not what we're talking about here. Counting is essentially figuring out the number of elements in a set given a certain type of information, which is not always trivial. And you need a little bit of practice and techniques in order to approach more complex problems in which you have to do this counting. But here's a little motivation, like I said, and it's a very simple problem. I mean, a simple question, in fact, that leads to one of the basic formulas. Oh, by the way, speaking about formulas, remember there's a formula sheet related to this chapter. You need to print it out already and make sure you use it when you go over homework problems. That's going to be available in Blackboard. So suppose, for example, that I know that at the college, a group of students take calculus and physics. So let's simplify this. Obviously, people take more than just 2 courses, but let's focus just on calculus and physics. And I know that 700 students take calculus. 500 students take physics. And suppose that we know there are 1,000 students in total. And here's the question. How many students take both calculus and physics? So try to actually answer this question using your intuition. It's not that difficult in this case, but I want you to focus on how you actually formalize this problem using mathematical notations involving sets. And then that leads to the concept of the number of elements in a set. One clue what goes on here, and by the way, if you have a question of in the sense of how do I know some of them take both calculus and physics, the clue, if you look carefully, is that the sum of the students taking physics and calculus exceeds the number of total students. So there must be some of them that take both, right? I mean, since 700 and 500 exceed the number of students in total. So that's how you can figure out, and how you can actually guess pretty quickly what that number is. We're gonna get to that if you didn't even figure out the number yet. But let's look at this problem in terms of set notations, right? So the problem gives you basically 2 sets if you look carefully. So you have the set, let's call it A, of students taking calculus, and you have a set B of students taking physics. Okay, now the 2 sets, if you were to sketch them with the 2 diagrams, they obviously overlap because the number of elements in each set exceeds the number of students. So you have calculus in this diagram, physics over here, and the overlap is both. But you know there are you know there are 1,000 students in total. So if I count them, if I take them all together only once, I know there are 1,000 students. Those who take calculus, like I said, are 700 of them. Those who take physics are 500 of them. But obviously, if I add the two, so if I add 700 plus 500, I obviously count the overlap, right? The both, taking both twice. Okay, so I hope it's clear from this diagram what goes on. All right, so if I add 700 with 500, I count in this summation those who take both courses twice. So therefore, 1,000 students in total, if you look at the difference, this is 1,200 compared to the 1,000 students total, the difference is the amount of students that is counted twice. So in other words, 2,000 is the number of students taking both calculus and physics. So this leads to the formula of one formula for counting the elements in a set, which we can formalize with a notation immediately. But take a moment for pause the video if you want and reanalyze this example and make sure you understand what goes on, because then you will understand how the formula works, although you don't have to memorize it, but it will be much obvious to you why it is as it is, right? The formula I'm going to write down immediately. So let's write a notation for the number of elements in a set. So using the notation we have in the homework, n of a, again, various notations in various books, but if a is a set, n of a denotes the number of elements in a set A. So in this case, for example, n of a will be 700, n of b is going to be 500. A union b, because this takes all the students without repetition, A union B means all students taken only once, which means in my example, the number of elements in A union B is equal to 1,000. These are all the students. What the question is really asking, what the problem is really asking, is the number of elements in the intersection, right? Intersection A, intersection B means students taking both physics and math. So what we call in this section the counting formula is simply a formula for the number of elements in the union of two sets. So the number of elements in the union is the number of elements in A plus the number of elements in B minus, because you count it twice, if you add up n of A plus n of B, minus the number of elements in the intersection. Once again, go back to the diagram here. If I add a number of elements in A, number of elements in B, I count the overlap twice. So I have to subtract it once so that you end up with the number of elements in the union. So this is what we did in this case. Basically, we solved the problem by replacing n of A union B with 1,000, because we knew that there are 1,000 students in total. 700 for those taking calculus, 500 for those taking physics, and we simply solve for the number of elements in the intersection by solving for it like we solve any equation, right? So 1200, move this to the left, move 1000 to the right hand side, and we get to 100. We're going to go over a couple of more examples with this. What you have to keep in mind is when you find these, when you do these exercises, it's very important to establish from the beginning the meaning of each set, and then use the counting formula and figure out what you need to obtain. So stay tuned for the second page. All right, so here's an example which is very similar to the previous one. So suppose, for instance, I say in a college, 600 students take calculus, 300 students take physics, and then 50 students take both calculus and physics. How many students in total? It's very similar, but it's asking a different question. Again, it's important to understand that the first thing to do is to establish the sets and what they mean. So you say, okay, the problem says I have a bunch of students taking calculus. So I'm going to denote by A the set made of the students taking calculus. And the problem says that the number of elements in A is 600. Then by B, the students taking physics. And the problem says that the number of students that take physics, right, it's 300. And then finally, those who take both calculus and physics, notice by definition that is the overlap, the intersection between the two. Students taking both. I guess one of the important things to keep in mind, there's a common mistake in the beginning. Sometimes people introduce a third set, C, saying that, okay, C is the number of, the students taking both calculus and physics. You don't introduce new sets unless you need to, right? I mean, once I established what A and B is, then a set operation, in this case intersection, refers to the third piece of information, namely that 50 students take both calculus and physics. And then again, the problem gives me the number of elements in that set, which is 50. How many students in total? That's another way of saying what is the number of elements in the union, right? Students in total, you take all the students taking either calculus or physics, taking only once, right? You don't duplicate the students in a set. This is simply asking what's the number of elements in the union. So of course, the same counting formula works. Except now I don't know the left side, but I know the right hand side. 600 plus 300 minus 50. And that gives me 900 minus 50, which is 850. So 850 students taking both physics and 850 students in total. Some problems in the homework will just give you, they're not word problems. For example, you could have, for instance, another example, find the number of elements in A, given that the number of elements in B is equal to 8, then the number of elements in the intersection is equal to 4, and the number of elements in the union is equal to 14. And the same counting formula works, obviously. N of A plus N of B minus N of A intersection B. And now plug in what you need know. 14 on the left equals N of A, which is not known. Give N plus N of B, which is 8. Minus N of A intersection B, which is 4. So we have 14 equals N of A plus 4, and then N of A equals 14 minus 4, which is 10. So N of A equals 10. All right. 8 minus 4. I'm double checked because my pen is running out of ink. You don't actually need ink, but now I don't actually see what I write on paper, and I have to actually look at the screen because I don't want to interrupt myself to reload the pen before I finish this page. But I think this is enough for this lesson. So that's 7.2, counting formula. Make sure in word problems you establish what the set means, and then find the remaining quantity from this formula. And that's it for today.